Hello and welcome to the first session in the Electricity Conference at ENIC 2020. We're going to be looking at preparing networks for the EV mass market. I'm Vicky Murchie and I'm the Stakeholder and Communications Manager at Scottish and Southern Electricity Networks, and I'm your host for this session. We're going to be hearing about four of Britain's most significant innovation projects in the EV space. Our speakers are innovation leaders from Electricity Northwest, SP Energy Networks, Western Power Distribution, who will be co-presenting with our project partners GHD, and my colleagues from Scottish and Southern Electricity Networks. We'd like to invite you in the audience to ask questions using the text chat function in the bar just to the right of your screens, and our speakers will be able to respond to you live throughout the session. To get the best experience, we do recommend limiting the number of applications you've got open and just double check there are not too many other devices consuming your broadband connection.
What is forecasting? When we talk about forecasting, we talk about long-term forecasting. This covers horizons that start from some years and go ahead into many decades. And importantly, for the transition to zero carbon, this need to go up to 2050. So when what we forecast is electricity demand, distributed generation, and battery storage. So why we do forecasting? We do it actually for two main reasons. The major reason is that we produce forecasts with a planning purpose. So we use the long-term forecasts of demand, generation and storage to plan our networks. The other main reason that we do forecasting is that as DNOs, we are becoming big data organizations. So there's a lot of data from measurements from our network planning, a lot of data that we process for the forecasts, and these are forecasts that we share with our stakeholders. So these forecasts are helping our local authorities to produce their decarbonization plans, for example, or our customers to make their decisions. So how can we do forecasts, long-term forecasts? There are at high level two ways to do it. One is using scenarios, and the other is using probabilistic assessments. Possibly most of us are more familiar with scenarios because they are already used by DNOs and the ESO and other network companies worldwide to, let's say, frame future uncertainties on demand and generation and use it into planning. The other way is probabilistic assessments that can be, let's say, that can have a significant computational cost. It can be more complicated approaches, but we understand they can bring us some very specific benefits that we need to take into account if we want to enhance our forecasting approaches. So a critical thing for forecasts is to understand the likelihood or understand the probabilities of potential future views of the world. Traditionally, we are using scenarios, and possibly most of you are familiar with the two axes that are used to frame uncertainties. So it can be an axis for decarbonization and level of societal change, and based on whether there is more or less of one or the other, we can use these two axes to define scenarios. Probabilistic assessments are using a different approach. So in a complete probabilistic approach, we would try to model all possible outcomes, but this comes at a computational cost. Currently, we don't assign probabilities into scenarios, but this is an area where we need to improve and try to capture these probabilities. So these probabilities, when it comes to scenarios, they are more associated with the inputs into the forecasting methodologies. So for example, when it comes to economic growth, we can use GDP forecasts from the Bank of England, and there are probabilities assigned. But for several other inputs, we cannot have that. So we need to really try to enhance our forecasting methodologies in a way that we can capture these probabilities. And when we produce a forecast, a scenario trend, we can say that it's this % of likelihood that this is, let's say, an outcome in the future. When it comes to using probabilities in scenarios, the reason for doing that is that, as we said earlier, they are used in network planning. So, for example, if we take into account the worst scenario into planning, we're going to use a least worst regret approach in planning. We're going to mitigate any risks in the future to facilitate, for example, electrification of transport or heating. If we use a central forecast, or let's say average assumptions in the forecast, it's going to be a scenario that is not the worst case, but has, let's say, more likelihood to happen in the future. So all these are ways that we are currently using to define scenarios and have a sense of probability of likelihood, let's say, of future outcomes in terms of demand or generation or battery storage. When it comes to a probabilistic assessment, the focus is to try and capture all probabilities around all factors that could affect future demand, generation, or battery storage. The existing scenario-based approaches have some gaps. Although they are a simple approach to produce forecasts, they cannot capture all probabilities. A main disadvantage is that they use two axes to frame uncertainties, and we cannot really not correlate all uncertainties around these two axes. So, for example, when it comes to the charging of electric vehicles, if we consider a decarbonization axis, we can understand if we are going to have more or less EVs in the future. But this doesn't answer the question of where, when, and how fast these electric vehicles are going to charge. EV charging is a critical area for DNOs. Our network planners need to understand, let's say, uncertainties about the future levels of EV charging at different parts of the network. Our headache is not about, let's say, plant developments for EV charging. It's more around the uncertainties. So, for example, if we want to facilitate the charging of taxis in the city center, and we know about it, we can plan our networks about that. But when it comes to understanding future behavior of users of EVs, it's something that it's not certain yet. So, for example, we don't know if they're going to charge more at home or destination, how many of them will use en route chargers, what capacities they will use, what times they will use. And these are uncertainties that can be different from region to region. So a critical thing for us to understand is, let's say, these uncertainties at a regional level. So, for example, in areas where customers have access to off-street parking, we understand that it's more likely that they're going to do overnight charging using their domestic chargers. When it comes to areas where we have significant traffic flows and service stations, we expect that en route charging is going to be, let's say, more dominant in those areas. We recognize that the current scenario framework cannot really help us to understand these uncertainties of EV charging at regional level. So this has led us to register the Reflect NIA project on EV charging. This project started on February 2019 and will be running up to March 2021. In this project, what we try to do is to use probabilistic assessments on top of the scenarios, and we do that to try and frame uncertainties on EV charging at regional level. We have 3 work packages in Reflect NIA project. We are working with Element Energy, who is our main forecasting partner in this project. In work package 1, which has finished, we've gathered and processed data that are related with EV charging. In work package 2, we are now developing and finalizing a methodology to model uncertainties on EV charging across the different regions in our network. The last work package is expected to be finished by the end of this project next March, and this is going to deliver a tool that will model these uncertainties on EV charging. And we're going to have, let's say, by the end of these projects, we're going to have a tool that will allow us have enhanced forecasts when it comes to how EV charging is affecting our networks, and we can be more able to model associated risks and costs when it comes to the different decisions in network planning to facilitate the electrification of transport. Our Reflect NIA project builds on our previous NIA projects. And more specifically, it builds on Atlas NIA project and our Demand Scenarios NIA project. Atlas NIA project was running from 2015 to 2017 and was used to develop a holistic approach in forecasting. It was using scenarios and was used to produce forecasts for the whole of our grid and primary network. Our Demand Scenarios NIA project has developed a real option CBA methodology and tools that are used for the decision making in network planning. So using these tools, we can make cost assessment and risk assessments for different network interventions and flexible services. So what we are doing in Reflect NIA project is to introduce the concept of micro scenarios. Micro scenarios is a set of scenarios with associated probabilities around each core scenario. They are produced through a probabilistic assessment, and they can be used as inputs into our real option CBA tool. By doing that, we can have more insights around probabilities, risks, and likelihood of different levels of electricity demand from EV charging across different parts of the network. Our Reflect NIA project is our first attempt to use probabilistic assessments of top-of scenarios to enhance our forecasting approaches. By doing that, what we try to do is cover the gaps from using scenarios in a traditional way. So any uncertainties that cannot be captured using scenarios, we want to produce some probabilistic assessment approaches that can capture them, and by doing that, we're going to enhance the use of scenarios rather than not using scenarios and using something completely different.
Thank you for joining us, everybody. It's a real pleasure to be here today to talk about the suite of decarbonisation of transport projects that we have been running at SP Energy Networks along with a number of partners over the last couple of years. As you will go on to see, the projects that SP Energy Networks has commissioned are considering different aspects of the decarbonisation of transport and thinking about all of our customers and how we can make that transition in an inclusive way. SP Energy Networks are doing a tremendous amount of work in this area and doing a lot of work with stakeholders like the Scottish Government, Transport Scotland, the Welsh Assembly Government and Liverpool Metropolitan Mayor's Office, in trying to understand what the low carbon transition looks like and ensuring we have coordinated policies and activities. We're only going to today talk about three of the many projects that we are actually delivering, and these are complementary in their nature. EV Up is a study looking at socio-demographic information and trying to understand which of our customers are going to adopt electric vehicles most quickly, and which of those customers face the challenges of not being able to charge at home. And then that leads us on to what can we do to service those customers and enable a universal access, universal transition to adoption of electric vehicles. The next project is Project PACE, which is the actual deployment of public charging infrastructure across 2 local authority areas in Scotland. It's delivering from start to finish around 10% of the public charging infrastructure that's going to be needed to enable 100% adoption of electric vehicles. The third project is Project Charge, and that is based out of their ManWeb network, and it is looking at EV uptake from a different perspective again. It's bringing together transport modelling, traditional transport modelling and network modelling, and looking at people's journeys and translating that into electric vehicle demand and producing a number of online tools for stakeholders to try and understand where should EV charging hubs be located in future?
Great. Well, like any good innovation project, it starts with a good name. So electric vehicle uptake modeling, or EV up, as we like to call it in SP Engine Networks, is a project which looks to improve our understanding and knowledge of when customers are likely to transition to electric vehicles. It takes a very innovative stance. Most modeling is very much from a top-down perspective. So what I mean by that is if you look at government targets, the recent 2030 target, it looks at very much at there's going to be X percentage of electric vehicles by a certain date, and then that's percolated down to a local level. EV Up flips that in his head and goes from a bottom up to look at what customers are likely to transition to electric vehicles first, based on a number of key parameters. So it's basically a tool to help us model the network, to look at what customers are likely to get an electric vehicle first, and crucially, what does that mean on local low voltage networks. The project is focused at domestic customers, so it's looking at, if you have a house, the key parameter for owning an electric vehicle, or the likelihood to transition to electric vehicles first, is the ability to charge off street. So it's likely that the early adopters of electric vehicles will be the customers. Not always the case, but will be customers who can maximize the benefit of off-street parking, of lower cost fuel, if you want. Now, if you get an electric vehicle and you can charge at home, the fuel saving from a conventional vehicle to an electric vehicle is up to about £1,000 a year. So it's a big saving for a general customer. So having the ability to charge and park at home is a key factor to the early adopters. So the project takes that information, looks at the customer's ability. So do they have a driveway? The second factor of the project is looking at what is the likelihood of that customer to transition. So we layer in demographic information, characterizes different households into different demographic groups. So are there a young family? Is it a large family? Is it an elderly couple, a retired couple? This third leg, or third thing that EV Up is looking at, is for the different demographic groups, there's different usage profiles. So if you are a commuter, or a salesperson, for instance, you might do high mileage. So layering up this local, very granular information at local level, we can then feed in different scenarios and understand the probability of different areas having high penetrations of electric vehicles, and actually what is the impact of that on our local networks. A key factor for the innovation project, and key factor for any innovation project, is ensuring that the data can be used in the business. There's no point doing an innovation project if it's a standalone project with no route to business as usual. So a key element of this project has been to bring in different stakeholder groups within the organization to ensure that we have a consistency, that the information can be used into the business. We've done that by using a common reference point right throughout the process, so that the information at the end can be readily adopted by our corporate systems. And that layering of data allows us to build up a greater picture as we move forward. So we took the decision at the start to model both our networks, so our SPD and SPM network. Doing a data project like this, having more data is beneficial than having less data, because it allows you to expand, to look at different scenarios far easier. If you're looking at a very small area, so for instance, Glasgow and Edinburgh have got approximately 60 or 70% flats, which is way above the national average of flats, terraced housing. Parts of Liverpool have got lots and lots of terrace streets. If you focus on a particular area, you'll lose the ability to improve the model across the entire network. So you've got to have that depth of data or scope to allow you to maximize the benefits. As you move forward, if you think about how people are going to charge your vehicles, there's different areas, different locations. So currently you have a petrol station. In the future, you're going to have more options, so you could charge at home. And maybe this is a key point in the importance of having quite a granular modeling, is that most modern services can cope with an electric vehicle charger. And currently that's a connect and notify. So the customer, if they have a modern service, is well within their gift to install an electric vehicle charger, and there's grants from central government, from dealerships, from manufacturers to install chargers. That's well within their gift, and most modern services can cope with that. The problem which can occur is if you have clustering of these. So if you have a street and you have 10 houses and they all get an electric vehicle charger at the same time, the network, the cable in between these houses back to the substation is not designed for electric vehicles. And that is one of the big risks. But home charging will be a key factor for customers, because they can have the ease of driving home and plugging in whenever they want. They can have the ability to have one bill if they want. For customers which don't have driveways, then public charging is likely to be really important, and that's where Project PACE comes in. The accessibility of these public charging, whether or not it's a fast, rapid or ultra fast charger. The next point after that is probably more of your petrol station, large filling station type charging hubs, or charging at businesses, so workplace charging. One of the challenges we've got as an industry is how do we articulate our concerns or our assumptions to key stakeholders, so customers, but also stakeholder groups like the Scottish Government, the Welsh Government, the UK, BEIS and so forth. So how do we articulate our concerns effectively? And having a very strong methodology, a robust model will allow us going forward to explain what our assumptions are and how we plan to enable or facilitate this transition to EV.
Project PACE is an innovative delivery model for the delivery of electric vehicle charging infrastructure, and it is being led by SP Energy Networks in strategic partnership with Transport Scotland and the Scottish Government, and working closely with local authorities, North Lanarkshire and South Lanarkshire, which are two of the largest local authority areas in Scotland. And the project is going to trial an innovative delivery model for public electric vehicle charging infrastructure across Lanarkshire, and it aims to deliver over 180 electric vehicle charging points across over 40 locations all across Lanarkshire by the end of March 2021. The electric vehicle chargers will all be located on local authority land that's currently owned by the councils themselves, and that prevents any issues with land rights and land ownership, and prevents long delays due to land ownership requirements. And these chargers will all be hosted by the local authorities, and they'll be registered on the Charge Place Scotland network, and will be currently free to use for consumers to use. So they'll be in areas like public parks, library car parks, community centres, car parks convenient for local town centres. So the first phase of the project was a sophisticated site selection study led by SP Energy Networks with lots of input from the local authorities, and this was funded by £500,000 of SP Energy Networks Green Economy Fund. So the site selection study looked at factors including network capacity, distance to the electricity network from these potential locations, and land and planning factors such as any environmental restrictions, land ownership, any potential planning restrictions, and also practical implications such as is there enough space in that particular car park for all the electric charging infrastructure and vehicular access. So the first of our sites went live at the beginning of August at Strathclyde Park. There are 6 chargers there. There are 3 rapid 50 kilowatt chargers that can charge your car in around about half an hour, and 3 22 kilowatt fast chargers that can charge a car in maybe 2 hours. And that site's been really popular with the local community. It's been used over 2,400 times in the 15 weeks that it's been live. We've also got 6 other sites across Lanarkshire that are currently live on the Charge Place Scotland network, and a further 18 in construction, so we're well on the way to delivering the 44 sites by the end of March next year. The sophisticated site selection process took in data from lots of different sources, so the network capacity data, like I said, things about land and planning, input from the council themselves, but we wanted to be able to provide public charging infrastructure in areas where there were lots of customers that didn't have on-street parking. So we took data from the EV Up project to make sure that across Lanarkshire, areas that did not have a large amount of off-street parking had a Project Pace charging hub nearby to be able to charge their vehicles. Project Pace wants to make sure that public charging infrastructure can be provided in a way that's universally accessible, in a way that leaves no community behind in the journey to net zero, and we're proud to be leading the way on that in Project Pace. One of the things we're doing as part of Project Pace is spending £1 million of Green Economy Fund money to support several community transport charities across Lanarkshire to buy electric vehicles, so electric minibuses, people carriers and cars, to support the great work they do across the community. And these electric vehicles will also be able to use the Project Pace charging infrastructure. And the benefit of this is it makes the transition to electric vehicles very real for the community, and it allows people from all walks of life, perhaps even vulnerable, potentially fuel poor customers, to get involved in what we're trying to do in supporting the journey to net zero. So we've just published the findings from our site selection study on our website, and the sophisticated site selection study that we carried out to develop the optimum locations for the EV charging hubs for Project Pace has shown that a saving of between £30,000 and £60,000 on average per location could be saved in connections costs, and this is a total of between 1.3 and 2.6 million for all the sites that are selected for Project Pace, and this is a saving to taxpayers in connections costs. And if this methodology was rolled out on a wider scale, you could save £26 million in connections costs across Scotland, and up to £310 million in connections costs if it was rolled out widely across the UK.
The Charge project is a 4-year innovation project that aims to accelerate the deployment of public charge infrastructure on the network, and it will do this by providing customers with unprecedented access to information on our network and information about where there is a requirement for public charging. And this is going to be delivered through the transport model, which simulates the movement of EVs on our network from 2020 up to 2050 and highlights where there are pockets of land where there is a high demand for charging. Secondly, we're going to trial and develop smart charging connections, and these smart charging connections will free up more capacity from the network, utilising the inherent intelligence of most modern day charge points to follow the available network capacity. And last but not least, this all culminates in the delivery of the Connect More online tool. The Connect More online tool will basically take the amount of time it takes to get a budget quote for the connection of a public charging from days to minutes, and it lets the customer drive their own connection, look at the options available, and ultimately access the network quicker and faster than previously. The overarching benefit of the Charge project is the accelerated deployment of public charge infrastructure, but the way that is going to be achieved is through delivering benefits to customers who want to connect, and that is primarily through faster and cheaper connections. So whether it's through faster being through the Connect More portal, which will get their budget quotes a lot quicker, or it's cheaper through adoption of a smart charging connection, or it's a more optimal investment by finding the most lucrative locations where there is demand and there is capacity, making the optimal investment for charge points. The project is funded through Ofgem's Network Innovation Competition, as well as complementary funding from ourselves at SPEN, and benefit-in-kind contributions from our project partners, EA Technology, PTV and Smart Grid Solutions. We're still on a recruitment drive is going to carry on for a couple more months. I think we're going to sort of draw a line under it at the end of January. And then we're going to basically look at the portfolio of locations we've got and decide what is the optimum solution to trial each location, and start developing the engineering design. So we've still got a couple more months of looking at options for sites. The first 18 months of the project has really been about putting the groundwork in, developing the smart charging trials, developing the transport model, laying the foundations for the Connect More tool. But as we head towards 2021, we've got some major milestones. As I said, we're currently on the recruitment drive for our smart charging trials, hoping to conclude that early in the new year, ahead of the trials commencing in June. Ahead of that, in March, is the first time we actually release something that's going to be in the public domain that is going to really benefit customers. And this is going to be the first time that the transport model and the capacity maps that we're generating are going to be merged. And we're going to put that on the public domain. And customers and investors alike will have ready access to this, and it'll basically help them identify optimal locations for charge points. And then towards the end of the year, we're going to actually launch the beta version of Connect More. So this will be the first time customers will be able to use the tool to generate quotes. At the same time, they'll still have the traditional route for getting connections available to them, while we iron out all any glitches that may be in the Connect More tool ahead of its full release the following year. So 2021 is a busy year for us, but it's quite exciting at the same time. As you'd expect, there's a wide range of activity in the market right now and in our industry, looking at EVs and how to accommodate them to the network. And they all have the same aim, is making sure our networks are ready and capable for what's coming. The mass adoption of EVs is going to have a major impact on our network, and it's all these projects at the core is basically making sure that we play our part, making sure that we're ready. What distinguishes the project is what the individual focus will be. And in the case of Charge, it's purely on accelerating the deployment of public charging infrastructure and the three core innovation elements. When you look at other projects that Spen's doing, EV Up is about forecasting the residential uptake of EVs. LV Engine is around delivering an innovative solution for rapid charging, and PACE is around a novel arrangement with the Scottish Government. And then you look to other projects delivered by the other DNOs. And they've all got their subtle differences, but their overarching aim of them all is really getting the networks ready and giving our customers options to connect. Well, quite simply, the net zero won't be achieved without the electrification of transport. There are other forms of ultra-low emission vehicles, but it's quite obvious that electric vehicles are the leading solution right now. They're not, the electrification of transport is not the only key essential ingredient. There is things about the continued conversion of our energy supply to 100% renewables, as well as the decarbonisation of heat, which is going to be a major challenge. But coming back to the transport, for the scale of adoption of electric vehicles that's required, it's going to be able to be, electric vehicles will be accessible to everyone in the UK, not just people with the ability to charge at home. And that's where the Charge project really plays its part. We're trying to make EVs accessible to everyone by really playing a part in accelerating the deployment of public charging infrastructure, so people who don't necessarily have a driveway or ability to charge at home can buy an EV confident that there's an abundance of charge points out there in the public domain that they can utilise with minimal impact on their day-to-day lives. So I think that's how we're contributing. But as I say, it's not the only thing that's essential for us to hit net zero, but it's a major component.
With the changes in climate change targets across the UK, these projects have never been more important. Each of them is scalable and could be rolled out by all the DNOs across the UK, and that's a really important aspect of the projects. There are other elements of the low carbon transition that are covered by other projects and are at the heart of all the projects we commission at SP Energy Networks in terms of just transition and inclusive transition, focusing on all our customers. So we are doing complementary work with Strathclyde University, looking at the impact on the uptake of electric vehicles on fuel poor customers and the impact on GDP and economic growth. One of the other key things which is at the heart of how all network operators function is public safety. and it's very important that our equipment in customers' houses is capable of providing the energy safely that is going to be needed, whether it be for electric vehicles or for heat pumps, as we decarbonise heat going forward as well. Thank you very much for watching, everybody, and thank you for your attention.
Hi, my name is Ricky Duke and I'm an Innovation and Low Carbon Network Engineer for Western Power Distribution. In this presentation I'll be taking you through our ENIC project, DC Share, and then I'll be handing over to my colleague Neil Murdoch, who will be taking you through the Take Charge project. So firstly, a quick overview of what we're going to run through. I'm going to quickly run through the WPD Innovation Programme and our strategy within that. I'm going to give you an overview of DC Share, the project aims, the progress we've made to date, the learning generated so far, and the next steps that we're going to continue on with. The WPD Innovation Team consists of a team of engineers who deliver our innovation strategy and values. So we identify problems, we then find solutions, and we trial them through our projects. And we have quite a big portfolio of both NIA and NIC projects at the moment. So our three core values are decarbonisation, excellence, and value for money. And we aim to be a main contributor to decarbonisation, and obviously doing this providing the best possible value for money for our customers. So our commitments from the innovation team are listed below there, so you can see we're committed to overcoming barriers to the energy transition. We're always looking to find novel ways of efficiently and effectively transforming our network, and we're going to continue to develop new technologies and new commercial solutions and standards to make the most out of our existing network. And we're also going to work with our communities to understand how best we can support our vulnerable customers and ensure that no one is disadvantaged. So we have 5 key priority areas within our strategy, and these include commitment to the government's net zero target, both through decarbonisation of our own network and facilitation of low carbon technologies on our network. These include the decarbonisation of heat, so the electrification of heat, the installation of heat pumps, decarbonisation of transport, and the facilitation of EV charging on the network. This is obviously a massive hot topic within the industry at the moment, and we have quite a few projects dedicated towards this. Engaging more with our communities and our vulnerable customers, so we can help them out some more. And unlocking the value within our data that we both hold and we can go for and collect on our network. And here we have some of our projects from our portfolio. So we've got a really good mix of network innovation allowance projects and network innovation competition projects. You can see a few other electric vehicle projects in there, such as Electric Nation Powered Up and Take Charge as well. So DC Share, what is it? So it's a 3-year project that kicked off in January of 2020 and it's going to finish up in March 2023. It's a £5.6 million network innovation competition project, and we're delivering it together with Ricardo, Turbo Power Systems, Electricity Northwest and VecDOS. So it's quite a big consortium involved in this project. So what is it? Well, with the rise in the uptake of electric vehicles, there's a need for rapid chargers to be placed in dense urban areas such as town centres and things to enable people to charge, get a charge for those who haven't got off-street parking and for those who dive into town to get something. So DC Share is a new and novel way of supplying the capacity to charge the vehicles using rapid chargers. So our conventional way, if we were to go and install some conventional rapid chargers into a dense urban area at the moment, we would have to replace the transformer. We would have to probably do some heavy reinforcement on the 11 kV circuits, all which is very, very costly. The DC share system, we're going to design, build and trial a meshed DC network on the low voltage system. So we're going to put DC converters into 4 distribution substations, link them together with DC cables, and then we're going to siphon off the latent capacity of these sites and be able to provide that for car charging. So rather than loading it all onto one site, we're going to spread the load across 4 in real time, and that should alleviate those reinforcement issues. We're aiming to trial new power electronics, more importantly the DC converters and the new DC to DC charge points, and use DC mesh networks in an innovative way. So we're going to link the distribution substations with different load profiles, so a couple of them industrial commercial type profiles, so top hat profiles like you see on the ones above there in the image, and a couple of residential profiles like the ones you see at the bottom there, the typical evening peak. And this will enable us to share the available capacity in real time. So the differences within those profiles will be able to push and pull across the network and use the latent capacity that we already have within our network. This latent capacity can be used to support the substations that are more heavily loaded and also supply the DC rapid chargers that we're going to be installing. So in the project, we're going to install up to 15 DC to DC rapid chargers, a mix of 50 and 100 kilowatt, and these will be placed around our installation network. Okay, so progress to date. Well, first off, we undertook quite a lengthy site selection exercise where we analysed all 130 odd local authorities within our 4 licence areas for many different parameters and factors, and we finally settled on Taunton within our southwest licence area as our trial location for the network. We have completed the initial design of the innovative elements of the DC to DC rapid chargers and the grid-tied inverters. We've done extensive modelling of the proposed DC network. We've gained all of our planning permissions for placement of the rapid charging infrastructure. We've had to go through a lengthy design for our communication and control system, so we've now drawn up the specification for this. We've drawn up the use cases of the DC network, and we've also procured the long lead items, namely the silicon carbide that's needed to produce the converters. So this is what our trial layout is going to look like once we've got it all installed. You can see at St Augustine substation, the Works substation, Hammett Street substation, Eastgate Garden substation, we're going to install the DC converters. We're going to install chargers. We're going to install 6 at Firepool car park there at the top. Coal Orchard is going to have 3, and Cannon Street is going to have 6. At Coal Orchard substation, we're going to have a control point. That's where all of our control systems are going to be housed, and the main control desk will be for the network. So all of these are linked through DC links, so there will be 2 DC cables going into each substation, looping in and looping out of the converters. So we'll be able to share it all the way around this capacity, or draw capacity from any one point of the network. So learning that we've generated so far. The main points we've learned already are based around the site selection process. So we undertook a really detailed site selection process to narrow it down to the right local authority. This included analysing current EV charging infrastructure, the number of electric vehicle registrations on the road, getting support from the local authority. And then we had to look at the technical aspects of it, such as finding substations big enough to house the DC converters, and had spare capacity on the network at that point to support the project. What we didn't anticipate is there was a lot more factors involved with this. So we have interacted with all kinds of agencies, from the Environment Agency to the Highways Authority, many different land agents, trying to secure small parcels of land or trying to get rights to cross to put our cables in. And all of these non-technical issues require careful and detailed analysis. So this is definitely something to factor in if you're going to undertake a large infrastructure project such as this. So the best scenario to conclude the site selections quickly is to only consider substations which are located entirely upon WPD owned land and already have sufficient space to house the new equipment within. So next steps. So we're entering a really exciting phase of the project now. Our final system design report is due the end of this year, and then we're going to start construction of the grid-tied inverters and the chargers the beginning of next year. We're going to complete and finalise the trial design to Ofgem by mid-December, as I said. We're going to procure the components for manufacture and the control system. We're hoping to do factory acceptance testing towards the latter part of next year, and then we're hoping to get our shovels in the ground and actually start installing the network the end of next year. And then of course we'll kick it off with a 12-month trial. So we will run through the different use cases and we will trial these across the DC network, followed by analysis and reporting. So thank you for your time and your interest in this project. If you'd like to find out more about it, please do drop online to the DC Share website at dcshare.org, or feel free to drop me a message at my email address there on the screen. Now I'm going to hand over to my colleague Neil, who's going to talk you through the Take Charge project.
Thanks for that, Ricky. Hi everyone, my name's Neil Murdoch. I'm the Engineering Manager at GHD, and today I'm going to take you through the Take Charge NIA project. So what I'm going to cover today is I'm going to provide an overview of Take Charge, the problem that we're trying to solve with the project, our proposed solution, the progress that we've made to date, the key learning, and what we're going to do next. Here is an overview of Take Charge. The project started in April 2020, and we've been currently working in the design phase, and we're shortly to be moving into the build phase. The project's due to finish in December 2021. The contract value for the project is just over 1.3 million, and we're working with GHD, Brush, Moto and Ecotricity. As I mentioned, we're currently in the development of the design for the connection solution. So what is the problem that Take Charge is looking to solve? Well, it's clear that the deployment of rapid EV charging is becoming increasingly important as customers want to have less time charging their vehicles and more time on the road. Motorway service areas were identified as a key location for the deployment of rapid charging facilities. However, with the increase in rapid charging infrastructure comes the need to provide additional power supply capacity. Unfortunately, a lot of these motorway service areas are supplied at low voltage, and there's not a lot of capacity on the network at that point. Studies have shown that to deploy EV charging across MSAs is likely to require a supply of up to around 20 MVA or even more for some of the larger MSAs. So what is our solution to make sure that we can get the power supply capacity required for all these rapid charging facilities across motorway service areas? Well, what Take Charge is looking to do is specify, design, test and trial a brand new standardised package solution that's able to be quickly deployed to site and provide a far more cost-effective solution than traditional methods. We've called this the Compact Connection Solution, and our plan is to be designed and built in conjunction with Brush, who are a leading manufacturer in switchgear and transformers. We're also looking to install this at a Moto MSA within our own licence area. It will be connected to our 33 kV network, and we'll be able to provide significant capacity for both existing EV infrastructure and new infrastructure. As I said before, this is really going to be a plug-and-play solution that's going to be far more efficient than our existing solutions. This slide provides an overview of the work packages for Take Charge. The first package looks at the system capacity optimization. That includes looking at which site we've chosen for the trials, and also looking to see how much capacity is required at that trial site. The second work package is all around the development of the solution, and we're currently working on the functional specification and the detailed design. The third work package is all around building the solution and installing it at the trial site. And finally, the last work package is the trial and evaluation of the new compact connection solution. So the next few slides, I'll talk about what we've done so far on Take Charge. As I mentioned earlier, the first key package for Take Charge was to select a site that we would use for the trials of the new compact connection solution. We achieved this by developing a site selection methodology. The methodology looked at 6 key areas: the proximity to the point of connection, the access to the MSA, the network configuration, the point of connection configuration, the space around the MSA, and the visitor usage. Using these factors, we were able to look at all the Moto sites within our license area and pick the most suitable one for the trials. After evaluating 13 sites in total, we chose Exeter MSA as the most suitable site for the trials of the compact connection solution. You can see a photo of Exeter MSA and also an overall site layout on this slide. The next part of Work Package 1 looked at calculating the capacity required for the new compact connection solution. Now that we had selected Exeter MSA as the trial site, we could start to look at things like the road traffic behaviour, customer behaviour, charging demand, the local infrastructure to determine how much capacity would be required at Exeter MSA. Taking all these factors into consideration, our engineers provided a forecast of where we would see the EV charging demand up to 2050. Our calculations showed that the EV charging demand would likely reach around 18 megawatts in 2050. The second work package looks at developing and designing the compact connection solution. We've been working with our project partner Brush to develop a functional specification for the compact connection solution. This has now been finalised and we're taking this forward now into the detailed design stage. It's important to note that we've used learning from SSE's MASK project within our functional specification. In addition, we're looking to focus the design around reducing the footprint, interfaces, maintenance and commissioning of the substation. Finally, we're looking to have a modular design that will allow for future upgrades with minimal disruption in cost. Through the work that we've completed on the project to date, we've generated some key learning. This learning has been captured in the project reports that we've published, and you can find these online on the WPD Innovation website. I thought it was worth highlighting 3 key areas of learning on this slide today. The first relates to the EV charging patterns at MSAs. Through work with Ecotricity and Moto, we're able to establish that EV charging patterns at MSAs were actually very similar to standard public charging patterns. This is really useful and helped us determine the capacity for the compact connection solution at Exeter. The second point focuses more on the functional specification for the compact connection solution. When we were looking at this, it was clear that the way we were going to produce the compact connection solution would have to be focused around the ratings of standard DNO infrastructure, and as such we've had to incorporate this within the functional specification. Finally, we looked at customer behaviour. Understanding how customers would behave and when they would charge their vehicles was important to understand how those would affect the charging patterns at MSAs. Using data from Moto, we were able to predict when customers might be likely to charge and how many customers might be charging at any one time. However, it should be noted that these behaviours could change in the future depending on how charging technology changes and how EV technology changes as well. So just moving on to our final slide now, what will we do next on Take Charge? Well, we've already completed Work Package 1 and we're currently delivering Work Package 2, and we're hoping to finalise the detailed design of the compact connection solution by the end of this year. When the design's complete, we'll move into Work Package 3, where we'll begin the build of the compact connection solution and start the site works ready for the installation. We're currently on track, and we're hoping that by the end of next year, we'll be in a position to complete our trials and evaluate the compact connection solution. That completes today's presentation on Take Charge. If you'd like to find out more information, feel free to go into the Innovation website and find out more details there. Thanks very much for your time.
Hi there, I'm Kate Jones from Scottish and Southern Electricity Networks. Today, my colleague Richard Hartshorn and I will be discussing preparing networks for EV-ready roads. The projects that we're discussing today are part of a wider portfolio delivering benefits in a number of key areas.
Hi everyone, Richard here. As Kate mentioned, we're going to be discussing with you how we're preparing our networks for EV-ready roads. So a key part of this involves first identifying where we're likely to see this EV uptake and crucially where we can expect the EV charge points to connect onto our networks. So to do this, we worked with sustainable energy experts Regen to produce detailed projections of EV charge point installations out to 2050 and under a number of decarbonisation scenarios. These granular year-by-year breakdowns are helping to inform the level of investment that's needed to accommodate the electrification of both domestic and non-domestic transport, which then allows us in turn to invest strategically and keep the cost and disruption as low as possible for our customers. You can find the data of these projections split out into output areas to support our stakeholders like local authorities who may be used to slicing and dicing data in that format and may want to use the data to inform their own plans on our website sscn.co.uk/LCT uptake. Now, the data indicates that there is likely to be a combination of both wide-ranging and highly localized challenges and opportunities relating to EV uptake. And we're proud to be delivering 2 innovation projects which are looking at those regional challenges and understanding the opportunities that we need to investigate further in a whole system manner to try and address any challenges before they come to fruition. So I'll hand back now to Kate to take you through how we're addressing those regional challenges through innovation. Thank you.
E-Tourism is a Network Innovation Allowance project, and it is investigating the scale, location and duration of increased charging demand, particularly peak demand during tourist season. This will allow appropriate actions to be developed and deployed to ensure network resilience and security whilst facilitating the growth of electric vehicles. We have undertaken a study to investigate 8 use cases. Using traffic data, the study allowed us to map predicted tourist driving patterns and develop charging profiles, which has been then mapped against our networks. The findings for the use cases we have investigated so far have indicated that tourist attractions in isolated rural areas and along popular tourist routes are expected to see the most increase in EV charging from tourists. Towns and cities have network capacity that is already sufficient for extra demand, and EV charging will be dominated by residential charging. Whilst isolated tourist sites are in areas where the network is less robust due to low residential demand, constraints are predicted from tourist EV charging in these places. In the more rural, isolated tourist attractions, we also see that seasonal charging will have a greater impact on secondary substations rather than primary substations. Interestingly, the seasonal tourist peaks are not just in the summer months, but any time around bank holidays. Although reinforcement is an option, perhaps the peak demand may be for a few days per year, and we might be better to identify smarter solutions based on local opportunities first. The report from the first phase is available on our website. We are currently investigating localised partnerships to perform 2 to 3 deep dive scenarios, where we can delve deeper into looking at smarter solutions to assist the network and look for optimum siting of potential EV hubs in tourist areas. We aim to develop an EV-ready tourist area whilst offering solutions which would provide greater resilience during the winter or in storms. The Level project could be one of these smarter solutions. The project is looking to develop a mobile charging unit which would temporarily connect to our network to provide a continuous supply of electricity. This would be rather than a battery which would deplete quickly, or a mobile diesel generator which would defeat the point of having an electric vehicle. This device would, say, live in a local authority depot where it would be trickle charged and dispatched as and when it's needed to provide short-term charging. There are many use cases where this could be of use, particularly when we think about local challenges. For example, this could sit in a tourist hotspot during the summer and then be used to provide network resilience in the winter. Scottish Fire and Rescue are looking to decarbonise their fleet and have range anxiety concerns, particularly in some of the regional fire services, which cover a geographical area 5 times that of the Metropolitan Police. This device could be dispatched to provide that extra support during remote, rural wildfires. The project is looking to trial a device early next year.
Thanks, Kate. So as you can see, we know there will be challenges from EVs on our electrical networks, but we are working hard to ensure that we've got the solutions in place to support our stakeholders and the communities that we serve by facilitating EV-ready roads. And I'd like to call out as well that this is just a small part of what we're working on to support the decarbonisation efforts. We've got a wide range of other innovation projects looking at everything from data sharing to whole system strategies and even supporting vulnerable customers, alongside other initiatives and strategies such as our electric vehicle strategy, which lays out the vision we're working towards, and the Accelerating a Green Recovery report, which contains a series of policy recommendations which we believe will secure a cost-effective and fair transition to EVs and importantly help the UK have the most extensive charging network in the world by 2025. And you can find both of these documents on sscn.co.uk/EV.
Thank you for listening to our presentation. We will be available for questions and answers after this session, but you can also find more information on these projects at the Scottish and Southern Electricity virtual stand.
Thanks so much to our speakers and to all of you for participating in our Preparing Networks for the EV Mass Market session. If you'd like to continue the discussion, you can head over to our innovation and exhibition halls, where you can access additional innovation project videos from the network companies, chat live with project leaders and technical experts, and check out the latest technologies on display on our interactive stands. Also keep an eye out for pop-up windows, which you'll see at the bottom of your screen, and that'll take you through to our 3 PM group chats. One of these will be following directly on from this session's topic, and that's looking at e-mobility. What do the networks need to do to enable the electrification of transport? And that session's hosted by Randolph Brazier. There'll also be a very pertinent group chat on innovation in ED2, and that's hosted by Ian Cooper from UK Power Networks. That's all from me just now, and I'll look forward to seeing you in this room again at 3:30, where we'll be exploring how to accelerate flexibility markets.